All right, I think we're going. Okay, so 2.6, this is going to be graphs of rational functions. So before we can get into actually drawing graphs of these things, which will be actually tomorrow that we're going to start doing that. But before we do that, we need to define what is a rational function for you guys. Okay, so let's start with something you're familiar with. What's a rational number? Mm-hmm. We did kind of talk about that when we talked about the rational root test, right? A rational number is a number that can be expressed as a fraction. So we often think of rational as kind of like the fancy word for fraction. Okay, so a rational function is going to look like a fraction then. And the way that it's set up is, if we call it r of x for rational, it's equal to a function, call it f of x, divided by another function, call it g of x, where f of x and g of x are polynomials. Okay, so that's why this section is included in Chapter 2, because Chapter 2 is everything polynomial. Okay, that's what we've been studying so far. And so a rational function then is one that's defined as a polynomial divided by a polynomial. Okay, and so those are going to those types of functions are going to have certain types of graphs that are going to look a certain way. But because of the nature of them, there are going to be some key components of those graphs, some properties and that sort of thing, that we can take a look at before we ever start to graph them. And the first thing we're going to talk about is something that we've discussed in the past, and that's vertical asymptotes. So in the past, what have we done to find vertical asymptotes? Yeah. Right. So that's where g of x equals 0. Okay, so we're going to be looking for those. We'll also be looking for horizontal asymptotes. Okay, so we talked about this in Chapter 1. Let's see what we remember. How did we find horizontal asymptotes? Yeah, go ahead. It's based on the degree of those two functions. Okay, so there's kind of a lengthier answer to this. We've discussed this before, but I'm going to write it out again just so we have it in front of us. So if the degree of f of x is more than g of x, what happens in that instance? Okay. Think about a horizontal asymptote essentially is talking about as x gets really, really large, what's happening to the value of the entire function. We're talking fractions now, okay? So if the degree of the top of the fraction, so we have a bigger number, essentially, as we go out, on the top of the fraction as compared to the bottom, okay? What happens to that number overall? if the numerator is larger than the denominator and continues to grow larger than the denominator. What's happening to the value of that function, or that value of that number? Yeah. Exactly. If your numerator is growing more quickly than your denominator, wouldn't that thing just take off? Right? It just keep getting bigger and bigger and bigger and bigger, right? So there is no horizontal asymptote then. That limit goes to infinity. So in this case, we would say none. Okay. So if it's the other way around, if the degree of g of x is more than f of x, so now we've got the denominator is getting way bigger than the numerator. Yes? Has to be 0, right. Think about that. If you have fractions where the denominator continues to get really, really big and the numerator not as big, you're making smaller and smaller and smaller fractions, right? And so that's going to level off at 0 then. So that's why this one comes out to y equals 0 is that asymptote. All right, and then there's the last case where what if it's the same? What if they have the same degree? So then they're kind of essentially growing at the same rate. But we talked about how the leading term of a polynomial is really the only part of the polynomial that makes a difference when you have really large x values, right? You guys remember that part of our little polynomial investigation that we did, right? Only that leading term really makes a difference for really large values of x, which is what we're kind of talking about right here, right? So if I have some polynomial, let's say like 3x to the 4th minus 2x to the 3rd plus x squared plus 1 over some other x to the 4th minus x squared plus 5 or whatever, okay? So in this particular rational function, okay, got a polynomial over a polynomial, as x gets really, really large, all of this and all of this doesn't matter. Only those two leading terms matter. So what's going to happen is determined by this. 3x to the 4th divided by x to the 4th. And what does that simplify to? Which is 3, right? So my horizontal asymptote there should be 3, because it's going to get closer and closer to 3 based on that. So, same degree, this is why we always say divide the leading coefficient for that particular reason right there, okay? Now that you have a little bit more polynomial theory under your belts, that should make a little bit more sense. Okay, so that's how we're going to go searching for horizontal asymptotes, okay, comparing the degree of one versus the other. The other two things we're going to look at that we want to know about these graphs before we can start to plot them are x and y intercepts. So, and we've done a bit of both of those. All right, so an x-intercept. So let's go back to our rational function here, f of x over g of x. X-intercepts are places where this entire function is equal to 0. That's what we've been doing, right, with polynomials. Set it equal to 0, try to solve it, and usually what we do to solve it is to factor it or something like that. Well, if I've got an f of x over g of x equal to 0, does it make sense that really the only thing we have to look at is where f of x is equal to 0? Because what's 0 divided by anything? 0. So if I want this entire function, f of x over g of x, to equal 0, as long as I can find places where f of x is equal to 0, I've done that. The denominator plays no role whatsoever in that. Does that make sense? Okay. So because 0 divided by anything is still 0, I just want f of x to be 0, and I've done it. So to find x-intercepts, that's where f of x equals 0. That's it. And then we are also going to be interested in finding what is the y-intercept of one of these. That's going to help us kind of put things together. Think of any function in the world. If you want to find a y-intercept, what has to be true about x at a y-intercept? Has to be 0, right? So what do you suppose is the process for finding a y-intercept then? Exactly. You plug in x equals 0. If x is 0, I have a y-intercept. Okay, so put 1 in there and see what happens. Okay, so those 4 pieces of information are going to be kind of our focus for today. If I give you a rational function, can you do these 4 things for me? Can you find vertical and horizontal asymptotes? And can you find x and y intercepts? And then tomorrow what we'll do is, once we have that information, then we can start to piece together what the graph looks like and kind of start to do some of these graphs by hand. All right, so let's give it a try. Okay, so there's a rational function. X squared minus 5x plus 6 over x squared plus 8x plus 7. So in general, it's going to make this process a lot easier for you if you start by just trying to factor everything that you can, that you see, numerator and denominator, because at some point you're going to need to use that information to get some of the stuff that we want. So I gave you 2 quadratics that are factorable here, and hopefully we can figure these out. And then once we do that, then we can keep going. So x squared minus 5x plus 6. What does that factor to? Mm-hmm. So x minus 3, x minus 2. Okay, and then that denominator, x squared plus 8x plus 7. Yes, you can. What is it? 7 and 1. X plus 1 and x plus 7. All right, so we got it in fully factored form here now. Let's go down our list, see if we can do each one of these things. Okay. Sometimes we're going to want to look at this one that's in fully factored form. Sometimes we're going to want to come back to this one over here. Depending on what we're doing, it might be easier to use either one. So we'll kind of take a look at that too. So let's start with vertical asymptotes. Kind of abbreviate here a little bit. Okay, so vertical asymptotes. We said we want to look where g of x equals 0. G of x is the denominator. So which one do you think I want to look at, the original or the factored one? Actually, no. The factored one. Why do I want to look at the factored one for this? Each individual factor is going to give you one of those asymptotes, right? It's where that denominator is equal to 0. So if these two things multiplied together equals 0, Where are my two vertical asymptotes at? -1, -7, right? Those are the two numbers that make that denominator 0. So yeah, having it factored is going to help. Okay, horizontal. So again, which form do you think is going to be more helpful in finding a horizontal asymptote? The original one, right? Because that's where we're taking a look at the degree of the numerator versus the degree of the denominator. And which of those two can I very easily see what the degree is? This one, the first one. Okay? So, what situation am I in here as far as the degree is concerned? They're the same. So if they're the same, what do? You divide those coefficients. And what are my coefficients? 1 and 1. So what should be my horizontal asymptote then? Y equals 1. Okay, so we got all of our asymptotes. Let's see, x-intercepts. So x-intercepts, we said that's where f of x equals 0. So where do I want to look for that? The factored one. Yes. F of x is the numerator. Okay, numerator. Where's that equal to 0? 3 and 2. Yep. So do you see how the vertical asymptotes and the x-intercepts you can just read right off of this thing once it's factored? Okay. That's why we did that. So x equals 3, x equals 2. All right, and then y-intercept, there's ever only one, so it's just the y-intercept. Which one do you think we want to go to? First one. Yeah. Okay. Remember, you're plugging in 0. Nice thing about that is, everywhere you plug in a 0, it turns it to 0, that whole term, right? So I can just go up to this original and say, all right, everywhere x is 0. Get rid of all of that. What do I have? 6 over 7, right? There you go. There's your y-intercept, 6/7. Okay, so that original is much easier for that. Just get rid of every term that has an x and what's left over. That'll be your y-intercept. Okay, so tomorrow what we would do with this then is we would draw these vertical asymptotes, draw this horizontal asymptote, put the x-intercepts in, put the y-intercept in, and then start to kind of piece together what this thing looks like all together. All right, for now, what I would like you to do though is let's graph this thing on our calculator and verify that all this stuff is right, that it looks the way we think it should. And be careful when you type these in that you use parentheses. Otherwise, it will not look right. So I'm looking at something kind of like that, right? X squared minus 5x plus 6 divided by x squared plus 8x plus 7. Both pieces have to be in parentheses. And if you have that in there correctly, then it's just a matter of making sure your window's the correct size so we can see everything. So if you look at all the intercepts and asymptotes we came up with, what's the biggest number you see? -7. So as long as we're out to 7 each direction, we should be able to see everything just fine. So maybe I'll just, to keep it a square window, we'll go -8, 8, -8, 8. See if we can see it all. And we might need to make it a little bigger just to get a better look at it. But in any event, all right, so probably want to make this window just a little bigger. So let's go, I think I'm going to go out to 15. Maybe that'll be a little easier to see it all. I might have to keep zooming out slightly, but yeah, this should be all right. All right, so this thing is kind of, what? How do I put them in? Yeah. Some calculators actually put them in, some don't, depending on what kind you're using. Actually, when the calculator does that, it's making a mistake. Because this calculator is trying to connect all the dots, and it plots a point like way up here, and it's like the furthest one up that it gets, and then the next one it plots is down here. So it tries to connect the dots together, and it ends up looking like a vertical line when it's actually not. So on yours, you have to kind of visualize a little bit where those would be, okay? But in any event, yeah, we should have a vertical asymptote at -7. So let's see, 1, 2, 3, 4, 5, 6, 7. And then we should also have another vertical asymptote at -1. And there's that one, okay? So we've got those both in there. We should have a horizontal asymptote at 1. Now on this one looks a little funky, but it is there. Remember, a horizontal asymptote is a number that the function approaches as it goes to infinity, okay? Now here's a really common mistake that a lot of students make about horizontal asymptotes. They assume that the function can never cross them. It is not true. A function can absolutely cross a horizontal asymptote. The key is, as the function goes to infinity, it approaches that number, though. So earlier on, your function might be going up and down and crossing that horizontal asymptote as many times as it pleases. But as you start to get larger, eventually it'll level off. And in this case, it's done that. And you see this little piece right here? It actually dips down, goes like down by 0, and then it starts to creep back up again. That's what this little line right here is. This is like a thick line. It's actually that function starting to creep back up. And what number do you suppose it's creeping back up to? 1, because that's your horizontal asymptote. But it crossed it, in fact, twice, down and then back up again. Well, no, I guess just once. It crossed it once. But in any event, yes, it can cross a horizontal asymptote. Just take a look as it goes out to infinity, what's going on. So the asymptotes are there. Intercepts. We said that we should have x-intercepts at what? 2 and 3. Now the window that we have right now, it's kind of hard to see. But remember I said it goes down and then it creeps back up again, right? So what it's actually doing is it's coming down right here, and then at 2, it dips just below, and then at 3, it starts to come back up again. So it's this tiny little boop, boop, and it comes back up. Okay? If you were to zoom in on that, you could see that a little bit better. In fact, I can probably do that real quick for you here. So it's supposed to be between 2 and 3. So I'm going to put a little box around it here so we can look at it. And let's make our window smaller. So let's have our Y's. Okay. I really zoomed in, but it happens. Okay. I really had to zoom in. But this is 2, this is 3. And it does actually come down and come back up again. So those x-intercepts, yep, those are right. It's in there. And then the y-intercept was supposed to be 6/7. So if I very quickly change my window again, 6/7 is supposed to be like almost 1. Okay, so take a look at that y-intercept. Is that right around 1, a little less? Yeah, it's there. Okay. So all of those key features that we calculated by hand are in the graph. Now this graph looks pretty crazy though, right? It's not like anything we've really studied before. And there's no one rational function that's like always looking the same as all of the rest of them. Okay, they all have asymptotes, they all have intercepts, but they can look all kinds of different crazy ways. Okay, so it's going to be a little bit of a challenge to put these things together for some of them. Some of them are pretty straightforward, some of them not. And we're going to talk tomorrow about some strategies we can use to try and figure out what exactly is happening, like between the asymptotes, that sort of thing. But for today, I just want to make sure we can do the calculation side of things first. So we're going to focus on that the rest of the way today. So, all right, let's try one more. I'm going to let you guys have time to do this on your own. Okay? Get through this one, we'll be done. Okay? So, let's see. All right, so let's do that. 5x squared minus 5 over x plus 4. So we all are here. Okay, so yesterday, this is where we ended up. We took a look at this particular function. We're able to come up with the vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts. We're going to do all that same stuff here with this next one, except the directions are slightly different where I want you to sketch it. So we're going to pull out all that information, put all of it onto a graph, and see if we can piece together what we have. Okay? So take a minute. See if you can get those 4 things we were talking about yesterday again. Vertical and horizontal asymptotes, and then the x and y intercepts. Okay, I will freeze this, and I will do the same, and we can compare what we got there, and then we'll move on after that.
Really bloody. Yep.
Now, one nice thing about this one, you don't have to factor it, right? So it should speed that process up a little bit. All right, if you're not done, don't look at the board. But for those of you that are, you can check how you did. Okay, does anybody need more time with this, or are we okay with that first part? Oh, go ahead.
Can you find the horizontal asymptote?
The horizontal asymptote is found by looking at the degree of the top versus the degree of the bottom of this fraction. If the degrees are the same, which they are in this case, then you divide the leading coefficients. So 1 divided by 1, y equals 1. Any other questions about any of the four of those before we move on? So we're all okay with that? Yeah, question. The y-intercept, you get a y-intercept by plugging 0 into the function. So 0 and 0, so negative 2 divided by 1 then would be negative 2. Okay, so let's start plotting this stuff out. Okay, so I drew a little coordinate plane down here underneath, and we're just going to start placing this stuff on there. So I'm going to make a little scale here, make sure it's all nice and even and pretty. Okay, so we've got a vertical asymptote at x equals negative 1, so that'll be here. And horizontal asymptote at y equals 1, so that'll be there. Alright, so you got both of those on there. And then x-intercept is at 2. That's right here. So there's an x-intercept. And we have a y-intercept at negative 2. That would be down here. Alright. So with all of this information on here, and I'll go ahead and finish up the scale I have on this thing. We want to see if we can kind of visualize what's going on as far as how this thing fits together. It needs to fit within the asymptotes, and it needs to make sure it goes through those intercepts as well. So let's talk just down here in the bottom right, because there's lots of stuff going on there. Can you guys kind of visualize in your head how this curve has to go? It has to fit within the asymptotes, and it has to cross those 2 points. Can you guys all see that? So it's going to be this curve that kind of comes up like this. Okay. So let's go ahead and fill out that part of it, because that, it seems, is fairly clear with how that should look. Okay, does that kind of a thing. So now the question is, though, is that it? Is there anything more to it? Well, we know there has to be, because in this particular case, the domain, the numbers that work in this function, should be everything except for negative 1, right? Negative 1 is the only part of the domain that's missing. So that implies that anything to the left of negative 1, there should still be something there, right? There should be a piece of that graph hanging out over there somewhere. Okay? The only thing is that part of the graph will never cross any of the axes, because all the intercepts that we have are on there. It's just those two. Just this x-intercept, just that y-intercept. So over here, we can't cross anything anymore. So remembering that these little pieces have to be caught in the asymptotes, could I have a piece that goes like this? Why not? It would have to cross the x-axis to do that, right? So we can't have one underneath this horizontal asymptote over here, because it would produce an x-intercept we know can't be there. So where's that other little piece going to have to go then? It's going to have to be up in here, right? And it's going to approach this asymptote and approach that asymptote. So it's going to be this little curve that's kind of caught like that in there. So we can finish off what this graph looks like then by doing that. All right, so this particular function that you guys started with here, x minus 2 over x plus 1, that graph should look like what you see underneath there then. Okay, so let's verify. Take out your calculator, type it up, see if we get the same thing. We should. It should be looking similar to this. And I would make, when you do this, your window, kind of like what I did here. If we just go out to 4 each direction, you should get a better look at it. Otherwise, it might be kind of small. And again, when you're typing this thing up, just be sure that you're using your parentheses, so it should look like that when you type it in. And then the window, like I said, we'll start with -4 to 4, just so it's the kind of the same scale I just made, and see if it looks the same or not. Sometimes these pieces that don't have any intercepts or whatever, they might be kind of a little further away than we anticipate, but see what it looks like here. All right, so not too bad, right? Looks pretty much the same. Now, your calculator doesn't plot the horizontal asymptotes, and in some cases, your calculators won't plot the vertical ones either, right? So mine does have the vertical one in there, and the horizontal one would be kind of right there, so you can kind of visualize what that would look like. But it's a good verification that, yeah, we got pretty much what we were supposed to get when we graphed that thing. Okay, looked like that. Okay, let's do one more of these. And the next one, this one was just to kind of get the ball rolling a little bit. This next one is a little bit more challenging. It's got a little bit more going on. Okay, so this is going to be kind of the entire process. All of those little things that might pop up that are going to cause you problems, we're going to look at those in this. Okay, so in this case, we're going to sketch x to the third minus 4x over x squared plus 2x minus 3. And as soon as I start to go for vertical asymptotes on this one, I realize, oh crap, I got to factor this thing first, right? So the numerator and the denominator of this are factorable. Okay? So let's see if we can come up here. Let's take care of that and rewrite it in factored form. So the numerator, how can I factor that numerator if it's x to the third? What do you notice? Yeah. Pull out an x, okay? And when I pull out that x, I have x squared minus 4. We'll come back to that. Denominator can be factored. Anybody figure out what those two are? Yeah, Josh? X plus 3 and x minus 1. Okay. Now, that numerator can be factored further, right? So if I have x squared minus 4, what does that factor to? Right. So here's what we're really working with. I'll make it nice and big so we can see it. X times x minus 2 times x plus 2 divided by x plus 3 times x minus 1. Okay, so like I said, a lot more going on this one than the last one. So let's see if we can look at that and get all that information that we need, though. Vertical asymptotes, where are they at for this one? -3 and 1. So x equals -3 and x equals 1 are our two vertical. All right, the horizontal asymptotes. That one we want to go back to our original, right? Take a look at the degree. The degree of the numerator is larger than the degree of the denominator. So what does that tell us? There's not going to be any, right? There are none. All right, x-intercepts. Take a look at that factored form of this thing. Where are the x-intercepts? 2 and -2 for sure, and at 0. So we have 3 x-intercepts happening on this one. Okay, and then the y-intercepts. Remember, to find a y-intercept, we simply plug 0 into the original function and see what we get. So what should that produce then? 0, yeah. Now think about that for a second too. That should make a bit of sense based on the x-intercepts we just came up with. If I have an x-intercept of x equals 0, shouldn't I have a y-intercept of y equals 0 too? Because an x-intercept of x equals 0 is where? Right at the origin, right? So you should have a y-intercept at that same place. Okay, so that just kind of verified that for us there. Yep. Okay, so let's get all of this stuff onto a graph. Try and make mine as pretty as I can for you here. All right, let's see. Okay, so quickly get this all numbered up here. Okay, so we've got vertical asymptotes at -3 and at 1. Okay, so -3. And at 1. No horizontal asymptotes, so I don't got to worry about that. X-intercepts, -2, 0, 2. And the y-intercept is already on there too. So, okay. So, let's take a look at this thing one piece at a time. Do you see how there are going to be 3 chunks to this thing? There are 3 different pieces. How do I know there are going to be 3 pieces to this thing? Yeah. Right. We have those 2 asymptotes which break it into 3 pieces. So there's going to be a piece over here somewhere, a piece caught in the middle, and a piece over here. Okay? So start with that. Use those vertical asymptotes to break it into however many chunks you have, and then kind of think about one at a time. And if you're like me, I like to just go left to right, or start with the chunk that has the most information if you'd rather do that. Okay? So maybe let's just do that. Let's start with the one that seems like we've got the most to go on, which would probably be the middle one, right? We've got these 2 points in here that it has to cross. We've got these 2 vertical asymptotes. So start trying to picture in your head, how could this go? Okay? There are really 2 possibilities, right? Without creating any more asymptotes, or any more intercepts, you could either have like a parabola-looking type thing that comes down, crosses here, and comes back up through there like that, or one that comes up through -2 and back down through 0 and goes down. Okay? And so then the question becomes, how do I know which way it's going to go? Yeah? Because the up because it's positive? Not necessarily. It's not like a regular quadratic. Okay, with quadratics we could do that. We said, oh, if the leading term is positive, it's going to open up. If the leading term is negative, it's going to open down. With these guys, all that kind of stuff goes right out the window, unfortunately. So really the only way to know is to test a point. Plug in a number and see what happens. Okay? So like, for example, in this interval, what do you think would be a good number to plug in to give us a sense of what's going on? -1. Okay, so I'm going to just hop over to the side here. If I plug in a -1 into the function, let's see what I get. So I get -1 cubed, which is -1, minus 4 times -1. So that's going to be -1 plus 4, so that's 3 on top. And then on the bottom, -1 squared is 1. It would be -2 minus 3. So 1 minus 2 is -1, minus 3 is -4. So I get 3 over -4. So that tells me that this point is going to be about -3/4. So somewhere like there. So now tell me, does it open up or open down? Definitely has to open up then, right? Okay. So it's going to look something like that. Okay, it's going to approach those two vertical asymptotes, has to hit all three of those points. We've got the middle piece done. Okay, let's jump over to the right. I know that this thing has to go through 2, and I know that it's going to have to approach this vertical asymptote somehow. So there are 2 possibilities here as well. Okay, it could come up through 2 towards the vertical asymptote that way, or it could come down through 2 towards the vertical asymptote that way. Okay, and again, how do we know? Well, we could try a point again, plug something in and test it out and see where it goes, and then connect the dots together that way. Since we're at the end, though, over here, we could take a look at some end behavior stuff. Okay. Now, if you guys want to just keep plugging in the points, don't want to worry about end behavior, that's totally fine. But it is another way to kind of quickly analyze things. So I'll kind of show you both ways here. So remember when we talked about end behavior and we said that you really only need to look at the first term for both, right? So if I just focus on the first terms of each, x to the third over x squared, what does that simplify to if I divide those two? Just x, right? Which means as this function goes to infinity, it should be going to infinity, right? As x goes to infinity, y should go to infinity. Okay? So it's going to be heading up like this, which means there's only one way this thing can go then, right? If it's heading up as it goes to infinity, it's going to have to come down through this point, approach the asymptote that way. Okay? Or, like we did before, you could just say, all right, I'm going to test 3. Plug in a 3 and see what happens. Okay? And what you're going to find is when you plug in a 3, you're going to get a positive number. And that tells you then, okay, I got to connect it that way, so it has to be going this same direction. So this piece, either way we slice it, it's going to look like that. So now we've got that part done. And then there's this third piece over on the left-hand side, which seems a little problematic again, because there's no intercepts past -3. So it's never going to cross the x-axis over here. Okay, so what could be happening then? How could I have a piece over here that never actually crosses the x-axis? What would it have to look like? It's got to approach that vertical asymptote somehow, right? So either it's going to go up the asymptote or it's going to go down the asymptote. So let's just assume for right now it goes up the asymptote, okay? So if it's going up the asymptote, then the other side of it can't come down and cross this. So it would have to come down, turn around, and go back up. Or, because there's no horizontal asymptote. If there was, then yes, it would have to level off and do that. But there's no horizontal asymptote, so it would come down, turn around, and head up. Or, could happen the same way underneath, right? It could be approaching this asymptote going down like that. So this piece would come up, turn around, and then head down like that. Okay? And we can approach this using the end behavior stuff again if we'd like. Okay? We know, again, we just focus on these first 2 terms, and we end up with x. So as x approaches -infinity, what happens to y with just x? -infinity. So which of those 2 is it going to have to be? Is it caught above or caught below? It's going to have to be that one that's below. So it's going to have a look that is something like this. So it's going to come up, it's going to approach that asymptote, but then it's going to head off and head down towards -infinity. Now, we don't know precisely like how far down this thing is, right? I mean, it could be like way down here, and we don't even know. Okay? So this is just a sketch. It's just I know it's not going to cross the x-axis, but it's going to have this kind of a shape over here somewhere. Okay? So if you were to actually like plug in points, like a -4, you know, it might, the way that I have it graphed here, it looks like this thing comes up to like -1, -2, but it very well could be like -30 or something. We don't know. Okay, but the point is, we've got the basic shape of the thing sketched out, though. That's what I'm going for with this stuff, okay? So you know exactly what the shape of it is, where it might not be like precisely lining up the way that you did it, okay? But let's take a look anyway. Let's see what we get when we graph this thing on the calculator and see how much or how closely it matches what we had. So we had x to the third minus 4x on top, and then divided by x squared plus 2x minus 3. And I'm going to go ahead and make my window just a little bigger. I'll go out to 5s, and let's see what we get. Okay, so I got that typed in. Made my window from -5 to 5 each way, and let's just see what we get. All right, so how'd we do? Not too shabby, right? At least for those two pieces. Now, like I said, that third piece, it's probably just really, really low. You can, if you bring it out to 10, you can see it. Okay, let's do that real quick. Yeah, see the little piece of it there? Yep, so we got the shape of that other little piece correct. It was just, you know, shuffled down a little further than we thought, but that's okay. That's fine. Okay? So, what I'm going to have you guys doing is a lot of practice with this kind of stuff, okay? Where you take a rational function, come up with the vertical, horizontal asymptotes, x and y intercepts, and try to piece together a graph. And it's going to take a little bit of problem solving, a little bit of guess and check, plug in some numbers, think in behavior. Okay, it's not always the same exact story for every single one of them, but you're going to try and piece it together the best that you can. And really be thinking in your head, based on what you see, what are the possibilities? Which way could it go without creating a new intercept or some new asymptote that wasn't there to begin with? Okay. After you do a few of them, you'll start to kind of get in the groove a little bit, and it'll make some more sense for you. But I got a little worksheet for you guys to practice with that. Once you're done with that worksheet, then you guys can start your homework today.